Yes, StreoChemistry. Okay, this is the subtopic which is present in all alkene chapters. Okay, please you have to be concentrate more. It is a very important topic. Okay, StreoChemistry. StreoChemistry is a branch of organic chemistry. StreoChemistry is the branch of organic chemistry which deals about the spatial arrangements of the atoms or group around the carbon atom. Okay, it will deals about the spatial arrangements of the atom or the group around the carbon atom. Okay, is known as stereochemistry. Okay, it will tell about the arrangements of the atoms. That means this atom is arranged either above the plane or below the plane or front or back. Okay, like that one, it will explain the stereochemistry. Okay, stereochemistry is the branch of chemistry which deals about the spatial arrangements of atoms or group. Spatial arrangements of atom or the group. Okay. So in this one, so we have to learn some of the points. First one is the chiral. Okay. So chiral. Okay, we can give the definition for the chiral is the atom or the molecule which are non-superimposable mirror images are called chiral compounds or chiral atoms or chiral molecules. Okay, or chiral objects. Okay, chirals are the objects which are non-superimposable mirror images to each other. Non-superimposable mirror images to each other is called chiral. For example, our left hand and right hand. Okay, this is the image of the left hand. This is the image of the right hand. If I take this image, okay, if I take this is the left hand, this is right hand. If I take these two images and keep one over to others. Okay, if I keep like this one, okay, so here they are not perfectly not fixed to each other. So therefore they are called non-superimposable mirror images. Okay, so they are called non-superimposable mirror images. Okay, examples are left and right hands. Okay, so the objects which are non-superimposable mirror images are called chiral compounds. Chiral compounds are chiral. Okay. Another example for the chiral is C. Okay, you can see the C. So if you write the mirror images for this one, how will you get any? You will get like this one. Okay. So if you take this one and this one, it will fit like this one. So it will not exactly fit one over to another over. That's why. So they are non-superimposable mirror images. Okay. So like that one other example for the chiral is spring. Okay, spring. You can see the spring. Okay, spring get out of so you can write this one spring. Okay, it mirror images like this one. So if I take this one and keep on this one, so it will not overlap to each other. They will not overlap to each other. That's why they are non-superimposable to each other. That's why the definition for the chiral is the objects which are non-superimposable mirror images are called chiral. The objects which are non-superimposable mirror images are called chiral. Examples are left hand and right hand, alphabet C and the spring. Okay. Next one is a chiral. Okay. So the definition exactly opposite to the chiral. Okay. These are the objects which are superimposable to each other. These are objects which are superimposable to each other is called a chiral. Okay. So example, okay, O or circle. If you give the mirror images, it will be this this one. So if I take these images and keep on this one, exactly it will fit over this circle. That's why they are superimposable to each other. Okay, that means they will overlap to each other perfectly, even mirror images to each other. That's why they are called a chiral. A chiral are the object which are superimposable to each other. They are superimposable to each other. Other one is alphabet H. Alphabet H. H. Okay. So if you write this mirror image in this one, if I take this one, exactly it will fit over this one. That means it will overlap exactly on the H alphabet. That's why it is a chiral. A chiral means the object which are superimposable to each other are called a chiral. A chiral. Okay. Next definition is optical activity. Next definition is optical activity. The optical activity is the rotation of plane polarized light. The phenomenon of rotation of plane polarized light either towards left side or right side is known as optical activity. Optical activity. Okay, what I am saying that one, the phenomenon of rotation of plane polarized light either towards left side or right side is known as the optical activity. Optical activity. This optical activity can be measured in can be measured in polarimeter. And this optical activity is physical phenomenon. Okay, physical phenomenon. Okay, it's a very important point. Optical activity, based on that one we can say whether that compound is optically active or not. Okay, optical activity or not. That means that will rotating the light or not. Okay, they are rotating or not. Okay, so that can be measured in the polarimeter. Okay, this optical activity is the phenomenon in which the plane polarized light is rotating towards the left side or right side. Right side is known as optical activity. Okay, so what I say that one, this optical activity is measured in polarimeter. Is measured in polarimeters. Okay, this is a schematic diagram how the plane polarized light is. Okay, so this is the ordinary light. This is the ordinary light. What is the difference between ordinary light and plane polarized light? What is the difference between ordinary light and plane polarized light? Okay, this is the ordinary light, which can scatter in all direction. The ordinary light will scatter the all direction. Okay, for example, in our home the tube light. In our home tube light, or in our classroom the tube light. The light will scatter throughout the classroom. Okay, whenever this ordinary light passed through nickel prism or any glass object. Whenever this ordinary light passed through nickel prism or any glass object, this ordinary light will convert into plane polarized light, PPL, plane polarized light. Okay, what I am saying that one, whenever ordinary light is passed through nickel prism, this ordinary light will convert it into plane polarized light. Okay, best example is our torch. Okay, we know that one, in front of the torch we are seeing either some glass. Okay, glass is there, glass circle will be there. Okay, glass circle. Just check it, just remove that glass, just torch. If you on the torch, what will happen? Okay, the light will scatter in all direction. Then we can keep that glass. Just on the torch. Just to turn the torch, you can see the light is passing in one direction only. Okay, light will pass in okay, one direction, some more length it will travel. That is the, okay, this ordinary light will convert into plane polarized light through the passing through the nickel prism. In plane polarized light, the lights are passing or scattering only in one direction. Only in one direction. That is the difference between ordinary light and plane polarized light. What I am saying that one? The difference between ordinary light, plane polarized light. Ordinary light is scattered in all direction. Plane polarized light will scatter only in one direction. Only in one direction. Best example, ordinary light is the tube light in home. Plane polarized light is the torchlight light, which can travel only in one direction. One direction. Okay. So what we say that today? We said this optical activity is measured in polarimeters. Polarimeters. Okay. In the polarimeters, okay, in the tube, okay, in some of the tubes, we will take the sample. We will take the samples. Okay. That means what we are saying that just we are checking that compound, organic compounds, whether it is optically active or not. Okay, this phenomena optical activity, what is saying that? So just we are checking some organic compounds or any other compounds, organic compound. Okay, is it optically active or not? We are checking through the, okay, polarimeter. We are checking through the polarimeters. Okay, how we are checking this one? Okay, how we are checking it? So we are taking the sample. We are taking the sample in a tube. Okay, taking the sample, the tube, and we are passing the plane polarized light. Plane polarized light. If the samples rotate. Okay. So first what we say that? So what we say, the phenom. First we say optical activity. What we say that? The phenomenon of rotation of the plane polarized light, either towards the left side or right side, is called optical activity. Is called optical activity. That means the sample or the organic compound must rotate the plane polarized light. Okay, either left side or right side. Okay, if it is rotate, that means it is an optically active compound. If the sample does not rotate the plane polarized light, that means optically inactive. Optically inactive. That means this sample must be rotate plane polarized light either left side or right side. Okay, so that means that is a optically active compound. If it does not rotate the plane polarized light, means it is optically inactive. Optically inactive. Okay, let us see. So what I am taking? So I converted ordinary light into plane polarized light. This plane polarized light is passing through the sample tube. Okay, what is doing this sample? So it is rotating the plane polarized light. In this case, this plane polarized light rotates towards the clockwise direction. Clockwise direction. Clock it will rotate this way. Okay, it is a clockwise direction. Okay, or right side. Clockwise direction or right side. If the sample rotates the plane polarized light towards the right side or clockwise direction, is called dextrorotation. Is called dextrorotation. Very important. Is called dextrorotation. What am I saying that one? So if plane polarized light rotates the sample rotates the plane polarized light towards the left side, towards the right side, is known as dextrorotation. Is called dextrorotation. If plane polarized light rotates, if the sample rotates the plane polarized light towards anti-clockwise or left side. Clock into this is the right side, the clockwise direction. It is the left side, anti-clockwise direction. Okay. If sample rotates the plane polarized light towards the left side, it is called levorotation. It is called levorotation. It is represented by small l or minus. Small l or minus. Okay. dextro rotation is represented by small d, okay, are represented by positive charge, okay. What I'm saying, plane polarized light whenever passing through the sample. So if the sample rotate the plane polarized light towards the clockwise direction or right side is called dextro rotation. It is represented by small d or positive charge. Okay, if the sample rotate the plane polarized light towards the anti-clockwise direction or left side is called levo rotation and is represented by small l or minus charge. Small l or minus. That means the sample may be rotate the plane polarized light either left side or right side. So then only it is called optically active. Okay, then only it is called optically active. If it does not rotate the plane polarized light either left side or right side, it is called optically inactive. Okay, so that means the sample must be rotated towards left side or right side. If it does not rotated means it is optically inactive. Okay. Yes. Next point is, what is the mechanism is involving to rotate the plane polarized light towards the left side or right side? Okay. So we have taken the sample. Okay, in the tube. Okay, we are passing the plane polarized light. Okay, we are passing the plane polarized light. Whenever light is passing, it is having the two charges. Okay, so it is sample is also having the two charges and this one. Okay, so up to now just you can remember this one. So if the sample rotates the plane polarized light towards the clockwise direction is dextro. If it is rotated the anti-clockwise direction, it is a levo compound. If it does not rotated, it is a optically inactive. Okay. So next, how can we say or how can we judge one organic compound without doing this polarimeter test? Okay, to say whether it is optically active or not. Okay, to say one organic compound is optically active or not without testing through the polarimeter, how can we say? Okay, so that we can say based on the structure of the compound. Okay, that means this is the chiral. Compound. Okay, that means the carbon which is having 4 different atoms are chiral. Okay, the carbon which is having 4 different atoms around it is called chiral. Here one methyl is there, here one hydrogen is there, one chlorine is there, one ethyl is there. Therefore 4 different atoms are present around this carbon. Therefore it is optically active. Okay, so that means all chiral carbons are optically active. Okay, so in this one, okay, example this one. Okay, here hydrogen is there, one. Okay, bromine is there, methyl is there, CH2Br is there. This is the one group, it is the second group, this is the third group, it is the fourth group. Okay, in this compound also, around the carbon, 4 different atoms are there. That's why it is a chiral carbon. Okay, in this example also, around the carbon, iodine, chlorine, bromine, hydrogens are there. Therefore, around the carbon again 4 different atoms are there. Okay, therefore it is also a chiral carbon. Okay, next one in this one. Here methyl is there, one phenyl is there, this ethyl is there, here OH is there. Therefore, carbon is having 4 different atoms. Therefore, it is called chiral compound. Okay, chiral compounds are optically active. That means the compounds which is having 4 different atoms are grouped around the carbon atoms are called chiral compound. These chiral compounds are optically active. That means they will rotate the plane polarized light either left side or right side. Okay, they must rotate the plane polarized light either left side or right side. Like that one, we can measure the optical activity through the polarimeter. Okay, this is the example for the chiral compound. This is the mechanism of the optical activity. Okay, optical activity is the phenomenon of rotation of the plane polarized light either towards left side or right side is known as optical activity. Okay, it is measured through the polarimeter. Very important for this one. So to exhibit optical activity, the compound must be chiral. Chiral means around the carbon atom 4 different atoms must be present. Around the carbon atom 4 different atoms must be present. Okay, so this is the optical activity, the definitions.